So I'm all mic'd up now. So this is the Sephora Center for Brain Sciences in Jerusalem. And the facade of that building, you see, has an interesting pattern. It's actually the pattern of neurons. And when you design something like that, you want to make it look properly like a little section of the top of your brain. You don't want to see a repetition. So we designed it and made sure there's not a single panel or not a single position within that design is the same. It's all custom. Problem then, if you want to engineer a facade like this, normally if you go do the engineer would go like, oh, okay, well, let's look at the worst case, because it was really about what the deflection and the wind was going to be. That was kind of the driving factor there. The problem is, you don't know. You don't know what the worst case is unless you go and analyze each one of these panels, right? But analyzing this panel manually took about a couple of days for the engineers. So what we did then is we wrote some code that really hooked on our design software, which is Rhino, together to an engineering software that we didn't even have to open the engineering software anymore. It was actually working in the background of Rhino, and it was telling us continuously what the deflection was going to be under a certain load case. So we almost had a continuous feedback, an engineering feedback within the design process. And it wasn't even the engineering itself that made it then interesting, because design also had to continuously be checked by the client, who is a very well-known brain scientist, which is Elon here in the front. I'm not sure it's really clear, there's a little light on there. So Elon was actually working with us together with engineering and together with, in the background, here's a fabricator, to come up with the perfect solution. So these were, let's say, workshops, not long meetings, actually proper workshops, 2-day workshops, where we were working with the client, engineering, and the fabricator all together. You can see that here. Another session with the fabricator. So we were able to kind of, where there was too much deflection, where the fabricator probably couldn't cut something or had some difficulties with attachments, we could continuously make slight changes and making sure the client was happy that it still looked like a section of the brain. And that project is now on site. And this is one of the latest mock-ups that we did. Another project, quite different. So this is a competition we did for NASA, where we're looking at habitat on Mars. Right? We did a previous project on the Moon with European Space Agency. This was a competition with NASA for Mars. What's particular about this project is that you see it exists out of 3 pods, interconnected pods. And to protect these pods, they need to be covered with a dome using local materials, which is just Mars dust. Right? And to get this thing built, we need to use an automated process. So we even designed our own robots, and we have 3 robots that all work together to create that dome. In the background, we have the digger, then the transporter, and the melters. And these actually melt the regolith, which is the Mars dust, together in a solid surface. So 3 little designs. But we thought actually, we want to actually kind of try this out. Does this really work? So we pushed it further. And during the Smart Geometry workshops and conference, we had the opportunity to do that. So we thought, well, let's go and build our own little robots and go and test this out. And great thing is, we have some guys in the team that have some robotics backgrounds, people with computer vision background. So suddenly we could go and test these things out. We built 10 of these robots. This is kind of the technical drawing of that, how it all came together. And over a period of 4 days, 6 tons of sand and a lot of hard work, we were able to set up a system where we have 10 robots working together, moving around sand according to a pre-described algorithm, right? Nobody was really driving these little robots. It was all automated, because the problem is with Mars, you cannot actually do operate anything directly, because there's always a 20 minutes delay between anything between here and Mars. So everything had to be automated. There's a good slide we saw earlier on today about automatic vehicles. Well, the same idea here. So the question is, of course, this might at some point really happen on construction sites as well. You know, this is us trying it all out. Now, let's bring it back. Let's bring it back to Earth now. I want to talk about design-driven technology, and not about technology-driven design. So technology for me doesn't drive the design. It's always the other way around. I had a conversation with somebody who, in a quite a large practice, was heading technology and BIM, and the question he asked me was, so what is your favorite digital design tool? And I was, well, that's a bit of an odd question for me, because that's a bit as odd as asking me, what's your favorite architect? Because each of these tools, you know, have their own functionality. To kind of explain even better, it's, you know, some of you might remember this. So if you ask this guy, so what is your favorite design tool? If you have to choose one, you can only choose one. Which one is it? Well, these are the design tools there, right? So back then, why would you have to choose one? They all have their own purpose. Some of them are more sketchy, other ones are more for detailed design. And you can probably order them, I think, from implicit sketching to really explicit drafting. How does that work? So, and I think design really works like that, is that you go from kind of an implicit idea, a sketch, a 2D sketch, you go to more and more detail until you get to the building, which is really the explicit form of it. And during that stage, I think you can actually switch between a lot of tools. I think the last 10 years, architects are starting to use more and more different tools. It's not anymore about choosing one piece of software that you think you can do the whole thing with. It doesn't really exist. You need to kind of be able to be more flexible about that. And then even if you go to, this is for our National Bank of Kuwait project, if you go to the construction stage, when you get your BIM models back from the contractors, from different subcontractors, they all give you different types of data as well. And how does that all kind of start to work together? So I think the flexibility in working in different platforms is really crucial. So this is that National Bank of Kuwait as being under construction now. And you see quite clearly, you know, in the cladding where we had about 4 contractors working together in the bottom there, how it all kind of now starts to come together. First the BIM models and now the real parts. And so that was a little bit about design, digital design technology. And I want to show you this slide. So this slide is a slide by a consultancy called Gartner, and they're a technology consultant. And each year they bring out a little graph showing different technologies and where they are. And they see development of new technology following this one line, which is technology trigger. Somebody somewhere invents a technology. Becomes more and more visible. It's, I guess, a peak of inflated expectations. People think that this new thing will change the world. And then you've got the trough of disillusionment. So people are a bit like, well, oh, it didn't work that way completely. And then there's a slope of enlightenment. People go work really through it and actually really find the real applications and optimize the process more. And I think it's interesting where you really pick up on certain technologies. And I think a lot of technology is actually following that curve, which you can see here. Some of these curves are really long, I would say, for certain technologies. Other ones, almost a bit of a sine wave until they actually kind of go up. An interesting one I find is, for example, augmented reality. We've seen it everywhere nowadays. It's everywhere in the press. But really, the first one was invented by a man called Ivan Sutherland in MIT Lincoln Lab in 1968. So then was the first VR system already developed. It took a while until it became almost a commercial thing in the 90s. And it's only now that it becomes really embedded. We're using it quite a lot. This is with a client using it. But I think what is really important is that we start to adjust these technologies to our own use. Like what I found, for example, is difficult to give an Xbox 360 controller to a client. Right? They have never held any of these things. So we're actually adapting these technologies now that we can do it without a controller, for example. Right? Another thing is that we find is just being on your own in a virtual space doesn't quite work. We're experimenting now with the HoloLens where you can be part of the same space, right? And what I found really exciting, that these things are not always that expensive. You know? We all have very good computers in our pockets. With a Google Cardboard, you can actually get into this really quickly and really easily. And this is the last technology I'm going to talk about, is 3D printing. This is the first 3D printer. Again, it's going to follow that same type of curve. This is the first 3D printer, 1986, Chuck Hull. Back then, it was a very difficult technology. It was not for consumers at all. It was mainly for industry. We got into it around 2004, where we were designing this large super yacht, which was great to do it digitally because you kind of make small changes and it actually kind of changes the curvature of this bird. The problem was how to follow it up with the physical models. We didn't have that link between the digital and the physical. So that was the reason we were pushed to actually really investigate, can we use 3D printing? And that became suddenly completely changed, I think, the way we work. Suddenly there were way more models. We already had to have loads of models anyway, but it just kind of way more physical models. We were able to kind of do it much more often, specifically as sketch models, as you see here, or also finished models. And this is how the project worked then. And very quickly, from just one printer, it became 2 and 3 and 4 in just a matter of months. Because we thought it was only going to be for special projects, but then we saw, well, you know, we can optioneer through projects much quicker now. And then out of that came a really large 3D printing facility, which you can all, if you're in Hester Road ever, you can actually see it from the street with about 8 machines, a really large facility now. But of course, we're in a very special situation that we can do that. So what other ways can you get into 3D printing? Well, if you can see on this graph, there is, you probably can't see on this graph, there is 3D printing, and can you turn this off because it doesn't work?